And then now re discuss about the objects in a lift. Re bolela ka a normal lift that you know, more especially in the shoppings. Let's say this is a lift and then only a person in this lift. More than two forces. Ranali a downward force, which is a weight force. And then ranali the upward force, which is you standing on this scale in a lift. So this is a normal force. The person standing in a lift. So now what is important again, you're in this lift. The scale on this lift measure your upward force, which is a normal force. So every time re nyaka find the force that the scale reads, re tla ba re nyaka your upward force, which is a normal force. So re la hore re tla ba re calculate a normal force. And then more nale some very important scenarios. Ranali a first scenario whereby a lift is stationary or it's at the constant velocity. What we know gore an object is stationary or it's at the constant velocity, the acceleration is 0. And then the acceleration is 0. This formula ya F net ilekana le MA. I will say F net equal to 0 because I substitute 0 here, it will create 0. And then for the reason ya F net ilekana le 0, all forces are balanced. And then remember more this situation. A normal force and then the gravity. F net is 0, these forces are balanced. These forces are therefore Fn ilekana le Fg. And then now Fn ilekana le Mg. So from there I find Fn. So that is something very important. An object is at a constant velocity or a stationary, acceleration is 0. And then F net will be 0. So F net is 0, the forces are balanced. Remember more only two forces. So that is why Fn ilekana le Fg. And then more another situation whereby a lift here upwards. And then let's see this free body diagram. A lift is going upwards. This force affect this force. Always reach the direction ya motion as positive. Object erna ya godimo, a force yellow leona kya godimo yoba positive, and then yellow is in the opposite yoba negative. So when using this formula, F net equal to MA, substitute these forces. Fn yoba positive and then the weight yoba negative. The reason weight is negative, this is because this lift here in the direction here Fn, not in the direction here weight, because weight get down and then Fn get up. So this formula. And then let's say this object is going downwards. So this object is going downwards. Now this object here in the direction here gravity. So because this lift here downwards, in the direction here weight. So this weight you are a positive. And then a formula F net e lekana le MA, and then from there re la hore re tlo re weight minus Fn. So ka kgona bona hore now this one is negative and then this one is positive. This is because you are in the direction ya weight and then not in the direction ya normal force. So this is a formula. And then ranali another scenario whereby a lift snaps mo ya senyega during the way. You are in a lift and then it happens or that lift has a function. The only force that is acting is the gravity. So the normal force you are 0. Remember a lift a measure a normal force, but in this case this lift is no longer functioning. It doesn't read anything. So the normal force is 0, and then the answer will be Fn equal to 0. But now we're level the practice examples. This question here, a boy standing in a lift on a scale. She has a mass of 60 kilograms. In each of the following cases, calculate the reading on a scale. What we know this scale reader the upward force, which is a normal force. Let's see question here, part A. The lift is stationary. What we know the lift is stationary, the acceleration is 0. Therefore F net is 0. And then for the reason our F net is 0, the upward and the downward forces are balanced, because morally only two forces, upwards and downwards. So these forces are balanced. So from there I will say Fn elegantly weight, and then I will say, and then mass is 60, and then gravity is always 9.8, and then R of 588 newtons. So this is the normal force. This scale reader 588 newtons, and then remember Fn is always upwards. So this is 588 newtons up. And then now our level part B. The lift moves downwards at a constant velocity. What is important here is this part here, constant velocity. This part is not important. Remember our previously the object is stationary or a mover at a constant velocity. The acceleration is 0. Therefore F net you are 0. And then probably the same thing as this one. So the answer for part B, it will be exactly the same as this one. And then now let's see part C. Part C, the lift accelerates up at 2 meters per square seconds. Now this object in the acceleration, so we can't say the Fn le Fg, because right at the constant velocity. So F net MA, and then this is our free body diagram. And then because this object here upwards, here in the direction of Fn, so this one you are positive, and then this one you are negative. So Fn minus weight MA, and then weight mg. So now let's substitute. So this is Fn and then minus 60, 9.8, and then 60. Acceleration bar filo 2. So mognally Fn minus 588, and then iliganally 120. Therefore Fn iliganally 120 and then plus 588. 588, and then re fa gore the answer ke 708 newtons. So this is our answer for part C. A re lebelele part D. The lift accelerates down at 2 meters per square seconds. So re dira the same way. F net e lekana le ma, but now lemoga gore ba re this lift accelerator downwards. So re la gore now we are in the direction ya w. So re la gore this one you positive and then this one you negative. So re la gore I will say w minus fn equal to ma, and then w e lekana le mg. And then this is 60, and then 9.8 minus fn lekana le 60, so more na le 588, and then minus fn equal to 120. So go to this 120 ka isha on the left hand side, and then ka fn ka isha on the right hand side. So re la gore fn e lekana le 588 and then minus 120. So re fa gore ke 468 newtons. And then a re lebelele part E. Part E the lift falls freely after the cables has snapped. Re la gore because now these cables ga di sa function, re la gore the normal force e over 0, because o ka kgona bona gore this object now is under the motion ya free fall. E re la gore e tsamaiša ke the gravity, so re la gore the normal force e over 0. So this is our answer for part E.